This is the second part of the video for section 10.1, and this is going to talk about signs of trig functions for non-quadrantal angles. So now we are going to expand. Instead of just being in quadrant 1, we are going to look at the entire XY coordinate plane. So first thing before we get started, let's remember that sine of any angle, again in standard position, is going to be y over r. Cosine of theta is going to be x over r. And tangent of theta is going to be y over x. Now this is going to be important when we're trying to determine whether or not these functions are positive or negative. When we were dealing with triangles, they were always positive because all of our dimensions were positive. But now that we're looking at positions and not necessarily triangles, we need to be aware that there are some times when these trig functions have negative values. So first of all, we need to label things. Our quadrant 1 here is when the x-coordinate is positive and the y-coordinate is positive. Quadrant 2 is when the x-coordinate is negative, but the y-coordinate is still positive. Quadrant 3 is when both coordinates are negative. And quadrant 4 is when the x-coordinate is positive and y is negative. So if we look at these trig ratios over here, we need to determine when y and x are positive to determine when sine, cosine, and tangent are positive. Now, since in quadrant 1 both coordinates are positive and r is always positive, r is always going to be positive no matter what because we have a square root, it's a distance. It's just whether or not x or y are positive or negative. So since both coordinates are positive in this case, all three trig functions are going to be positive. And again, this is just a table of when things are positive. Now when we look at sine in the second coordinate, y is positive, so sine is going to be positive. Cosine relies on x, which is negative, so cosine is going to be negative, and tangent relies upon a positive divided by a negative, which would be negative. So in quadrant 2, sine theta is the only thing that is positive. And again, that's all we're concerned with here, no values, and we're not getting too specific. We're just determining whether the trig function is going to produce a positive or a negative ratio. In quadrant 3, both things are negative, so sine is going to be negative with y being negative, cosine is going to be negative with x being negative, and tangent is actually going to be positive because we have a negative number divided by a negative number. So tangent of theta is going to be positive in quadrant 3. And then if we move over to quadrant 4, in this case, y is negative, so sine will be negative. X is positive, so cosine will be positive, but tangent will be negative because you have a negative divided by a positive. So cosine of theta is positive in quadrant 4. And there are several anagrams and phrases and things like that that go along with how to remember this. A lot of times we'll just put an A, an S, a T, and a C to remember. So if you were going around clockwise, you would get act. A lot of people like to stay in the order the quadrants go 1, 2, 3, 4, and there's a phrase that says all students take calculus. So however you choose to remember it, just make sure that you can remember it because this is going to come into play when we start doing inverse trig functions to go backwards to find the angles. Another thing to keep in mind here is that since each trig ratio is positive in 2 quadrants, we need to be very careful again when we're dealing with inverses because technically sine in quadrant 1 and sine in quadrant 2 are going to give us the same ratio. Tangent in quadrant 1, tangent in quadrant 3 are going to give us the same ratio, and cosine in quadrant 1 and cosine in quadrant 4 are going to give us the same ratio. So let's try a few examples with drawing these out. So in this case, we've got -4 and +3 as our point. And again, we can draw over here. We also actually talk about these as being reference angles. We are always making our triangle with the x-axis, so the theta that we're talking about now is actually measured up in this direction, or you can think about it from this direction, but to think about it as a triangle, it's a little bit easier to look at the one that I've drawn there with the theta. So again, first thing we need to do is find r. So r is going to be the square root of -4 squared plus 3 squared. So we end up with 16 plus 9, which is the square root of 25, which simplifies to be 5. And it's possible that you could see that this is a Pythagorean triple, 3, 4, 5. Now in this case, sine of theta is going to be the y value 3 over the radius 5. Again, this is positive because we're in quadrant 2. Cosine of theta is going to be the x value, -4, divided by r, which is 5. And again, cosine in quadrant 2 is negative. Sine is the only thing that's positive. And tangent of theta, in this case, is going to be the opposite, or y value, 3, over the x value, or adjacent side, -4. And typically we like to pull that negative out front. Again, we're in quadrant 2, so tangent is going to be negative. The only trig ratio that will be positive is going to be that 3/5 for sine. So I want you to pause the video at this point and try example 6. So in this case, you should have found that your radius was the square root of 13. And again, always make sure that you draw the picture with these and label your angle as theta. Theta is going to be coming down from the x-axis, the positive x-axis in this case. And we should have found that sine of theta, when simplified, was -3 root 13 over 13. Again, we're in quadrant 4, so that makes sense for sine to be negative. Cosine of theta comes out to be 2 root 13 over 13, and again, cosine should be positive in quadrant 4. And finally, tangent of theta was -3/2. Again, tangent should be negative in quadrant 4. The only one that should be positive is cosine. So take a second, make sure everything that makes sense, and then we're going to move on to the values of the quadrantal angles. Now, the quadrantal angles, as you recall, are the angles that are on the axes. And this is a little trickier because essentially we're dealing with values of 0 and 1. So suppose we end up with x and y values of 1 if we're on these axes. Now, if we are at 0 degrees, our y value is 0. So this would be the point 1, 0. This would be the point 0, 1. This would be the point -1, 0, and this would be the point, 0, -1. So again, if we look at our ratios, in this case we're going to assume that r is 1 for all of these, because if you take the square root of 1 squared plus 0 squared, you get 1. If we look at 0 degrees, we end up with y being 0 and r being 1. So we have 0 over 1, which is just 0. For cosine, our x value is 1, radius is 1, so this comes out to be 1. For tangent of theta, we have opposite, which is 0 over 1, which comes out to be 0. And then if we look at our reciprocal trig identities, if we flip these over, cosecant becomes 1 over 0, which is undefined. Secant is 1 over 1, which is still 1. And cotangent also becomes 1 over 0, which is undefined. So I want you to take a second here and fill in the rest of this table. It's also located in your book if you want to review. So in this case, sine and cosine are the only ones that end up with anything that is not undefined. Tangent, cosecant, secant, and cotangent all end up with some undefined values because those are the reciprocals and we are going to be dividing by 0. For 90 degrees, you should have had that sine was 1, cosine was 0. Tangent was undefined because you're taking sine divided by cosine. Cosecant, if you take the reciprocal of sine, you get 1. Secant is going to be undefined because it's 1 over 0. And cotangent is going to be 0 which is technically the reciprocal of what we have for tangent. Tangent is 1 over 0, so if you flip that over, you get 0 over 1. 180 is the first time we get to negative values. We should have gotten 0, -1, 0, undefined, -1, and undefined. Again, something to kind of point out here is that tangent and secant are going to be undefined at the same point because you're dividing by cosine in both of those. Cosecant and cotangent are going to be undefined at the same points because you're dividing by sine when sine is 0 in those points. Again, take a look at this table, make sure everything makes sense based on the trig ratios that we talked about, and then this will come in handy again when we start talking about graphing these trig functions and these trig values. This concludes the video for section 10.1. Please go online now and complete the homework for this section, and then watch the video for 10.2.